The answer to this one should be 125. The answer to this one should be 265. The answer to this one should be 29. Pick a number from 1 to 5. The winning number is 4. If all of your homework is complete and you have work shown for everything, then bring it up here. 12 out of 20 with homework, that will be 60%. Here are the answers. I'll show you what the answers are, then we can go over questions after we get through the last answer. Number 1 is 1 plus or minus square root of 97 over 8. 2 is 5 plus or minus I square root of 87 over 14. 3 is 5 plus or minus square root of 89 over 16. 4 is 1 plus or minus I square root of 29 over 5. 5 is negative 1 plus or minus I square root of 7 over 2. And in this case, remember, you had a negative on the bottom, so you multiply everything by negative 1. Makes that negative, but this, remember, does not matter since you have plus or minus. Problem number 5. It's already in the right form to begin with, so if you do your discriminant, you'll have a negative 1 squared minus 4 times negative 1 from the A and negative 2 from the C. So that's 1 minus 8, which is a negative 7. So we're going to end up with a complex answer. Go back to the formula. Negative negative B plus or minus the discriminant. We already went through that. Square root of the discriminant. Over 2 times a negative 1. That negative 1 is from the A. So double negative is positive. Take out the square root of negative 1 to get an I. Then square root of 7. On the bottom you have a negative 2. Multiply everything by a negative 1 to get that negative off the bottom. When you do that, it's a negative 1 plus or minus I square root of 7. Remember, this doesn't matter, because we went through that example where 3 different ways that you do it, you still come up with the same answers. The only difference here is when you don't have the negative in front of this, the answers show up in a different order, which doesn't matter. As long as you have the right numbers and the right signs, everything is good. So you could have, if you had a negative there, I won't take off, but we'll make it positive from now on. And then a positive 2 on the bottom. Same thing for 6. 5 plus or minus square root of 13 over 6. 7 is 1 plus or minus I square root of 3 over 2. On problem 7, this should be first, so we'll move it out to the left, but it did not change sides. We have a 2x, it doesn't need to change sides, but this 3x does. So it's a negative 3x. And then this negative 1 goes over, becomes plus 1. Now simplify 2x minus 3x to get negative x. And now you're in the right form. So the discriminant is negative 1 squared minus 4 times 1, which is A, and times 1, which is C. So that's 1 minus 4, a negative 3. So we have a complex answer on this one. Use the formula. Here's B. This is B. So negative negative 1 plus or minus the square root of negative 3 over 2 times 1. 1 comes from the A. If you simplify, you get 1 plus or minus I square root of 3 over 2, and there's nothing more to do after that. 8 is negative 1 or a half. On problem 8, it's not in the right form, so we're going to move this minus 2x squared to the left, but it's not going across the equal sign. Neither is the 4x. But the 5x must, so it's minus 5x, and then you have a plus 1 that stays there on the left. Simplify 4x minus 5x to get negative x. The discriminant is negative 1 squared minus 4 times negative 2 from the A times 1 from the C. That's 1 plus 8, which is 9. Anytime you get a perfect square for the discriminant, it's going to be a neat answer. It may end up still being a fraction, but that's better than the i's and all that stuff. So in your formula, your negative b is negative negative 1, plus or minus the square root of the discriminant, 9. Then on the bottom, 2 times negative 2 from the A. So it ends up being 1 plus or minus 3 on the top and a negative 4 on the bottom. Now whenever you end up with something as neat as this, you don't have to multiply everything by negative 1 right now, because this isn't your final answer. You can go through and evaluate it and then see what you end up with. So 1 plus 3 over negative 4 is going to be a negative 1, and 1 minus 3 over negative 4 is going to be a positive half. 9 is 7 plus or minus square root of 73 over 12. And 10 is negative 5 plus or minus 2 square root of 7. On number 10, it's already in the right form. So the discriminant is b squared, that's 10 squared, minus 4 times a, which is 1, times c, which is negative 3. That comes out to be 112, which is real. Be wary of multiples of 4. Anytime you have a multiple of 4 for the discriminant, you know it's going to be able to simplify. 4 goes into 100, so it's got to go into 112. In the formula, here's your negative b. That'll be a negative 10 plus or minus the square root of 112 over 2 times 1 from the A. Well, that's still a negative 10 plus or minus, but actually 4 is not the highest that comes out. It's 16. I started with 4 and noticed that I had 28 left. So clearly you could have taken out another 4. So it's square root of 16, square root of 7, which dwindles down to this. You have no negative on the bottom, but you can divide everything by 2. So that divided by 2 is negative 5, this divided by 2 is 2, and this just cancels out. Today's objective, still the same thing, solve quadratic equations with real coefficients that have complex solutions. Here's an example, and you can answer some questions as we go along. Is this in the right form? No. What is the first thing that I could write?
X squared.
Yeah, x squared. We're just going to put it out there. What can I put next? X. That's from the same side, so it doesn't change signs. What can I do next? Yeah, move this negative 2x over and make it plus 2x. Now what? Negative 4, and it doesn't have to change sides, so it's still negative 4. What's next?
Change the negative 1 to a positive, and then set it equal to 0.
That's right. This had to change sides. Any questions about what we just did there? Okay. What can I do to simplify first?
Keep your x squared.
Keep the x squared.
And then combine your x and 2x.
X and 2x will give me 3x. Now what?
And then combine your negative 4 and 1.
Negative 4 and 1 will give me a negative 3. So we're in the right form now. Any questions up to this point? Okay, so we need to do the discriminant. What do I write first for the discriminant?
3 squared.
3 squared comes from the b, and then what? Minus 4 times a, which is 1, and c, which is negative 3. All right. What do I get when I get 9 minus, actually it's plus, 12? What's the discriminant? 21. Anytime, including the minus sign, anytime you have an even number of these, you'll have an even or a positive answer. If you have a negative number of these signs, it'll be negative or minus. So the answer is real or complex? Should be real. Going to the quadratic formula now, the b is 3, so we have a negative 3 plus or minus the square root of the discriminant, which is 21. All of that over 2 times a, which is 1. So a negative 3 plus or minus. Can I do anything to the square root of 21? No. And on the bottom we have a 2. Is there anything I can simplify? No. This is it. This is not in the right form, so we must put it in the ax squared plus by plus c equals 0 form. Start with x squared. No more x squares. We have a minus x. Minus 2x must change to plus 2x. You're crossing the equal sign. This 5 stays on the left. This must go to the left, cross the sign, and become minus 6. Next up, we have to simplify, so x squared minus x plus 2x is plus x, and 5 minus 6 is negative 1. For the discriminant, the b is 1, so we'll do 1 squared minus 4 times a, which is 1, times c, which is negative 1. And we have 2 of these signs, so it's going to be plus. 1 plus 4 times 1 is 4. So all of that is 5. You're going to have a real answer. So on the next page, we will use the discriminant of 5 and then the b of positive 1 to solve this out. Alright, continuing on with the formula, negative 1 for the b, the negative b, and then plus or minus the square root of 5 over 2 times 1 for the a. The a was 1, right? Okay. So negative 1 plus or minus the square root of 5 over 2 is the final answer. Answer to the bonus should be 12. The answer to this bonus is negative 7. We have to put this in the right order, and notice that you have 4x squared and x squared on the same side. So just go ahead and make that 5x squared, and then minus 3x. This must go to the left and become minus 6. The discriminant is negative 3 squared minus 4 times 5 times a negative 6. That's 9 plus 20 times 6 is 120, so it's a 129. And it should be a real answer. How many had 129 for the discriminant? So that's good. Now we'll go to the other page and use the discriminant of 129, the b value of negative 3, as well as the a value of 5 to finish this off. In the formula, we should have a negative 3 plus or minus the square root of 129 over 2 times 5. So that's a positive 3 plus or minus the square root of 129 over 10. Can the square root of 129 be simplified? No. And there's nothing else to do to simplify, so this is the final answer. Answer to the bonus is a negative 76. The answer to the bonus should be 29. Answer these out loud. What would be the solution to this problem? Quick way to do this is you have 4 minus 2. Think of it as 4 minus 2. That's 2, which is really 2x. And then this one, if you move it over and change the sign and add it, it's a 24. So you have 2x and 24, so the answer should be C, 12. Or if you work it out, it's 4x minus 2x equals 16 plus 8, which would be 2x equals 24 still. And then 24 divided by, that's a terrible 2, that would be 12. What would be the answer to this problem? Negative 3x minus 2x. It's a negative 5x. Move that 10 over. It would be negative 5 minus 10. So that's a negative 15. Negative 5 times what is negative 15? 3. So it would be B. Last one. What would be the solution to this problem? Negative 1 plus 2 is a positive 1, so it's just x. So whatever we do now is going to be the answer. Negative 8 plus 3 is negative 5. I should call these the ACT mid-quiz problems or something like that. And we'll answer most of these out loud instead of turning them in. On the ACT, you only have a certain amount of time to get your stuff finished. And the quicker you can go and the quicker you can see a pattern and remember shortcuts, the more likely you are to finish on time and get a higher score. Example 3. The square root of 104. How could I simplify the square root of 104? What's a perfect square that could go into 104? And it doesn't even have to be the highest to start with. She says 4. So we know that 4 goes into 100 25 times, so this will be 26. Can I get a perfect square out of 26? Which one? No, we cannot. So the square root of 4 is just 2. 2 square root of 26 would be the answer. Example 4. The square root of 68. Can you think of a perfect square that comes out of the square root of 68? Or just 68? 4. Square root of 4 and the square root of 17. Can I get a perfect square out of 17? No. Square root of 4 is 2. So 2 square root of 17. On the quadratic formula problems, most of the things you can simplify by will be the 4. Sometimes you will have higher ones, but it's just not as common for the problems that we do. Try one and drop it off. (76). If you can remember that 4 goes into 60, if you can remember a reference number of your own choosing that you know is divisible by 4, the higher the better. Like 60, I know that 4 goes into 60 15 times. The difference between 60 and 76 is 16, and that's divisible by 4. So is 76. So if I can get 15 from this and 4 from that, then 4 goes into 76 how many times? 4 plus 15? 19, yeah. So it would be the square root of 4, square root of 19. Can't get a perfect square out of 19. So it's just 2 square root of 19.